Hello everyone. Today we'll discuss about PN junction diode or a semiconductor diode. When P and N type semiconductors are joined together, we consider this as a P and N type semiconductors. If these two are joined together, then it forms a diode. And this terminal, we call it as anode, which is a positive terminal, and this terminal is a negative terminal, cathode. This is the structure of diode, and the symbol of the diode is represented as arrow symbol, where this is anode and this is cathode. Initially, when a diode is formed, it means when a P and N type semiconductors are brought together and joined, then diffusion takes place. Diffusion means holes here in P type move towards N type, and electrons, which are the majority carriers in N type, move towards P type. This process is called as diffusion. And after some time, a junction is formed here with the free electrons residing at this junction and the free holes residing at this junction. So this junction is called as a depletion region. Now, when these diodes are unbiased means if there is no external supply connected. Okay, so when there is no external supply connected, then we say that the diffusion process takes place and there is also a depletion region formed. If in case, if we make the connection, that is, if we connect an external supply, a DC supply, connecting positive of the DC to positive terminal or anode and negative of the supply to the negative terminal, then this is biased now. The diode is biased. In this case, this is actually a forward biased condition. Means when positive terminal of the supply is connected to positive of diode and negative terminal of the supply is connected to negative of diode, then this is said to be forward biased. So in forward biased, the diode is said to be the diode conducts. The diode conducts current. And in reverse biased, so reverse bias means negative is connected to positive and positive is connected to negative. Then the diode is said to be reverse biased. So in reverse bias, the diode does not conduct. In forward biased, as the forward voltage is increased, the depletion region width decreases. And in reverse biased, when the reverse voltage is increased, the depletion region width increases. It means voltage versus current characteristics of a diode. Voltage versus current characteristics. So if a diode is forward biased, then it operates in the first quadrant. It means initially when the diode is forward biased and if you increase the supply voltage, the current is very minimum up to the threshold voltage. It means up to the. So if a diode is forward biased, then it operates in the first quadrant. It means initially when the diode is forward biased and if you increase the supply voltage, the current is very minimum up to the threshold voltage. It means up to the barrier potential. The depletion region is having some barrier potential which will resist the flow of current. And up to this point, for example, if it is a silicon diode, then this is 0.7 volt. And after 0.7 volt, if the forward voltage is increased, then the current is linear. So in reverse biased, as we know that the current does not conduct, means the diode does not conduct. As you go on increasing the reverse voltage, the diode does not conduct. Only the current is due to a minority charge carriers, and which is very negligible. And if you increase beyond this threshold voltage or breakdown voltage, which is mentioned as VBR, then the diode or the large current flows at once, and there may be chances of damage to the diode. So therefore, diode is only operated in forward bias, not in reverse bias. Okay, it means the diode is preferred to be operated in forward biased.